Hello there everyone, it's me, Helen the Great, and if there's one thing you need to know about me is I really don't like remembering things. I would rather find tricks or just understand why they happen. So that's why I've developed these tricks or this understanding of the laws of exponents. Okay, x to the power of m times by x to the power of n is equals to x to the power of n plus n. It feels very abstract. So let's change it to 3 to the power of 4 times by 3 to the power of 2. And we'll write it out in expanded notation. Now I'm going to do 3 to the power of 4 in green. So that's 3 times 3 times 3 times 3. 3 multiplied by itself 4 times. And now I'm going to write 3 to the power of 2. So we've got 1, 2, 3, 4, 5, 6 3's being multiplied together. And that's very easy to change to 3 to the power of 6. So this law is recognizing that there's a pattern between the exponents and the final answer. If we write the whole expression out as expanded notation, we'll find that it gives us 4 plus 2 is 6. Okay, well the next one, make a pretty arrow. X to the power of m divided by x to the power of n is equals to x to the power of m minus n. Once again, sounds far too abstract, so let's change it to 3 to the power of 4 divided by 3 to the power of 2. I hate the divide sign. I would rather change it to a fraction. So 3 to the power of 4 over 3 to the power of 2. Let's write that as expanded notation. 3 times 3 times 3 times 3. There are 4 3's because it's 3 to the power of 4. And at the bottom, 3 times by 3. Let's cancel. 3 cancels with 3, and 3 cancels with 3. And that leaves us with just those two. So we have 3 to the power of 2. Do you see the pattern that's been recognized? 3 to the power of 2 was the final answer. 4 minus 2 gives us 2. So in other words, the laws of exponents are the tricks that someone else has found to make our lives easier. And that's what maths is all about. Now x to the power of m to the power of n is equals to x to the power of m times by n. Now once again it sounds awful. So let's do 3 to the power of 4 to the power of 2 and see what happens. First thing I'm going to do is deal with the bracket. So 3 to the power of 4 is just 3 times by 3 times by 3 times by 3. We still have it to the power of 2. Now whenever we square something, it means we're multiplying the number by itself. So let's write that out in expanded notation. 3 times by 3 times by 3. I'm trying to do it as fast as possible, but I'm sacrificing neatness. I'm sure you understand. We'll do the last 2 times 3's. Okay, how many 3's are multiplying each other? 1, 2, 3, 4, 5, 6, 7, 8. Remember that when brackets are touching, we multiply the 2 together. So our final answer is 3 to the power of 8. What do you notice about 4 times 2? Well, it gives us an answer of 8. So expanded notation helps us to see what's really happening. Now this last one I've had a little bit of fun with because it's a little bit more difficult to show. If I've got 3 squared and I multiply it by 4 squared, why will it give me 3 times 4 squared? Well, let's play with it a bit. I'm going to change it to 3 times 3 times 4 times 4. And this is now mathematical. Look at this. I take this 3 and I put it over there. And I rearrange this 4 to come back to it over there. Now I take this 3 and put it there. And I multiply it by 4. Are you ready for the mathematics? I'm going to put brackets around there and around there. Look, I've got two values that are exactly the same that are being multiplied by each other, which means I have 3 times by 4 squared. So the pattern is, if the exponents are the same and the bases are being multiplied by each other, you can put the bases in brackets and the exponent on the outside. Maybe this one is a little easier to memorize off by heart, but the rest should make you feel happy that you don't have to remember them, you just have to write them out in expanded notation and then they make sense. Now, just underneath it we have definitions of exponents. I love doing that last one, but let's start with this first one. X to the power of negative n is equals to 1 over x to the power of n. In order to prove that one, I'm going to take this other law and use it there. And I'm going to say 3 to the power of 2 divided by 3 to the power of 4. Now, of course, I don't like dividing or the divide sign, so I write it as a fraction. 3 to the power of 2 divided by 3 to the power of 4 gives us 3 times by 3 over 3 times by 3 times by 3 times by 3. And we'll do some cancelling over there and over there and over there and over there, which gives us 1 over 3 squared. Now, how does that link to this over here? Well, if I had just done the straightforward following of this over here, I would have got 3 to the power of 2 divided by 3 to the power of 4 is equals to 3 to the power of negative 2, because 2 minus 4 gives me negative 2. Now that value has exactly the same value as this one over here. And that's what's so exciting. So now we know that 3 to the power of negative 2 can also be written as 3 to the power of positive 2. Okay, this last one. Why is x to the power of 0 equals to 1? If we have 3 to the power of 2 and we are dividing it by 3 to the power of 2 and we change it to a fraction, we've got 3 to the power of 2 over 3 to the power of 2. Well, in normal mathematics, we can just cancel them, and we get to an answer, let's try this color, of 1. But we also know that there once was 3's over there. That doesn't really link up to it. We can write this problem over here as 3 to the power of 2 minus 2, which gives us 3 to the power of 0. So when we follow the laws of exponents and we do this problem over here, we get 3 to the power of 2 minus 2 is equals to 3 to the power of 0. Now that means that 3 to the power of 0 has a value of 1. In other words, any base that has a power of 0 is going to equal 1. Okay, lovely one. Much love.